When solving mathematics, we often do not use all elements of number sets. We just need part of them. The most used number sets is sets of real number. So in this session, we discuss about the commonly used subsets of the sets of real number R. In mathematics, we usually see following subsets of the sets of real numbers R. Firstly, open interval. That means x, e, and elements of the sets of real numbers, so that x, e greater than a and x, e less than b. Okay, and this is the number line. You see, the opening parentheses represent for x, e greater than a, and closing parentheses represent for x, e less than b. Open interval from a to positive infinity. That means x, e, and elements of real number. So that's x, e greater than 8. You see, from a to positive infinity, and from the negative infinity to b. So that's x, e less than b. The second closed interval, we have from a to b. Okay, x, e, and elements of real number. So that's x, e greater than or equals a, and less than or equals b. And this is the number line. You see, the opening square bracket represent for x, e greater than or equals a, and closing square bracket represent for x, e less than or equals b. And the third half open interval from a to b contain x, e, and elements of real numbers. So that's x, e greater than or equals a, and less than b. Okay, this is the number line. You see, this is the opening square bracket and closing parentheses. However, this is opposites. X, e greater than a, and x, e less than or equals b. Next, from a to positive infinity, and from negative infinity to b, and this is the opening square bracket and closing square brackets. The symbol positive infinity is reset, okay, and this is negative infinity. We can write R contain negative infinity to positive infinity, and this is an open interval. Okay, it's open interval. With any real number x, we also write x is greater than negative infinity and less than positive infinity. Remembering that always use parentheses for infinity. is wrong when we use a square bracket for infinity. That means we cannot write or it's wrong. Okay, it's wrong. The exercise. I have you to show some of the exercise and you have to finish the rest. Determine the following sets and represent them on the number lines. Problem 1. A. Have open interval from -3 to 1. Union have open interval from 0 to 4. Okay, unions, that means we take on elements up to sets and it's a closed interval. Okay, this is the result. C. Open interval from -2 to 15. Union the open interval from 3 to positive infinity, and the result is an open interval from -2 to positive infinity. We take all the elements from two sets. The first open the first, okay, and the second, and we take on is equal E, the open interval from -infinity to 1. Okay, union open interval from -2 to positive infinity, and the results is an open interval from -infinity to positive infinity, or R. Okay. Problem 2. A. Have open interval from -12 to 3 intersect with a closed interval from -1 to 4. This is the first set and this is the second set. In the set, that means we take the common elements that are in this set and in this set too. So we see this interval is the common. The results is a closed interval from -1 to 3. There are common elements up to sets. Next, open interval from 4 to 7. In the sets with an open interval from -7 to -4, you see there are no common area between two sets, so the result is an empty set. D. A half open interval from -infinity to 2. In the set with an half open interval from -2 to positive infinity, and you see this interval from -2 to 2 is their common area, and the result is a closed interval from -2 to 2. Closed interval from -2 to okay. Problem 3. An open interval from -2 to 3 minus another open interval from 1 to 5. That means we take elements that are in this set, but are not in this set. So we realize that an interval from -2 to 1 is in this set, but not in this set. This is the result. A half-open interval from -2 to 1. You see, 1 is an element of this set, but it is not an element of this set. And this is the result when we use the symbol. And this is the result when we use normalize. C R minus an open interval from 2 to positive infinity. That means an open interval from negative infinity to positive infinity minus an open interval from 2 to positive infinity. And you see, this is the interval that is in this set, but is not in this set. And you know, number 2 is an element of this set, but is not an element of this set. So the result contains number 2, 2. This is the result when we use the normalize, and this is the result when we use symbol. Remember that we never use parentheses for infinity on the normalize. We just use parentheses for the result while we use symbol.